Hi everybody. Today my topics is second order non-homogeneous linear differential equation. Here I put one equation a d square y by dx square plus b dy by dx plus cy equal to m. It is a second order linear differential equation. As well, it is non-homogeneous because right hand side I put here m, and this m means it is a function of x. So, or if I consider m as a constant or function of x, then this equation is non-homogeneous. As well, left hand side I have three constant like a, b and c. As well, this equation I can write like this. In terms of d, we call d as an operator, and it is the expression, I mean d equal to d by dx. And as well, this number one equation, if right hand side there is a 0, it is homogeneous. If it is not equal to 0, it is non-homogeneous. Now, the same equation, only the things I changed, right hand side I put function of x. So it is a non-homogeneous equation. So to find the solution of this equation, I mean general solution, we have to find two things. One is complementary functions, another is particular integral. Once we get these two, I mean yc and yp, we have to sum up these two, then we will get the general solution. Here the expression like this one. Now I am taking one example, d square y by dx square minus 5 dy by dx plus 6y equal to x square. To solve this equation, first we have to consider a homogeneous equation. How to get that? Left hand side will be as it is, only right hand side if I put 0, so this equation will be considered as homogeneous equation. Now we need to find auxiliary equation. In my previous video, I explained how to get the auxiliary equation, but here I am taking it directly from this equation as k square minus 5k plus 6 equal to 0. How it comes? This is second derivative, so it is k square. Here first derivative, so it is k. Constant will be as it is. Here 6, constant will be as it is 6, but y will be 1. Now we have to do factoring. By factoring, what I get? Two factors, k minus 2 and k minus 3. It means k equal to 2 and k equal to 3. These are two roots, and these two roots are real and distinct. If we look at the discriminant b square minus 4ac greater than 0, here we can see it is 1, it means greater than 0. So k1 and k2 are real and distinct roots. So the equation, it is showing here complementary function like this one. But from this equation, I mean in homogeneous equation, we get two solutions. y equal to this and y equal to this. It is two parts. Here actually combination of two parts. So if we add these two, we get the complementary function as c1 e to the power 2x plus c2 e to the power 2x. This is the complementary functions. Now our target is to get particular integral, because already we got complementary functions. So to get general solution, we have to get now particular integral. How to get that? This equation, right hand side function of x equal to x square. We can see it here. It is a polynomial degree of 2. So we have to try something similar to this. So similar to this, we have to try like this type of equation, ax square plus bx plus c. Then this equation, we have to find first derivative and this is second derivative. So first derivative and second derivative, once we get it, we have to substitute these two values in this equation. What we get? We can see it next slides. Here, substituting into differential equation, we get like this. This is 2a. We got in previous slide, this is second derivative. This one first derivative multiplied by 5. This is value of y multiplied by 6. I mean, we considered y equal to x square plus bx plus c. So multiplied by 6, we get this. So more simplifications, we get this. We rearrange it from this equation. How? X square coefficient, x coefficient, and this is constant. Now this left hand side, if we compare it with the right hand side, what you can see? This is x square, here x square. So this 6a equal to here constant 1, so 6a will be considered as 1. This x coefficient, but right hand side there is no x, no coefficient, so this coefficient will be considered as 0. As well this full coefficient, right hand side there is nothing, so this will be also considered as 0. Now our equation comes as this one. 6a equal to 1, already I wrote in previous slide, this part equal to 0 and this equal to 0. Here also I mentioned one important points. Polynomials are equal when their coefficients are equal. From that point of view, we got these three. Now, solving these three equations, we get a equal to 1/3, b equal to 5 by 18, c equal to 19 by 108. Now we have to substitute these three values a, b, c. In the particular integral, we considered this equation as for our trying. This is the equation. We assumed x square plus bx plus c. Already in the previous slide we got the value of a, b and c. So substituting this a, b, c, we get particular integral like this one. And general solution now, it will be summation of complementary functions and particular integral. This one particular integral, and before we got complementary function. So adding these two, we get our general solution for this equation like this one. This is the general solution. Now I am taking another example. Difference is previous equation, right hand side was x square polynomial. This is exponential type, e to the power 2x. To solve this, I mean to find general solution, first we have to solve complementary functions, then particular integral. So to get complementary functions, I have to take an homogeneous equation like this one. Left hand side will be same as this, only right hand side I will consider is 0. So auxiliary equation will be same like this is second derivative, so k square, this is first derivative k, constant 8 as it is 20, and y will be 1. Now solving this, what we get? We found that we have to use quadratic formula to solve this. What is quadratic formula? This one. It comes from quadratic equation. So this is quadratic equation, we get this formula. Now putting the value of a, b, c, we get it is in the form like this. 8 plus minus square root of 64 minus 80 divided by 2. Plus or minus, it means there is 2 roots. So what is that 2 roots? 2 roots are here one important points. These equations, I mean these roots, what we got, it is a complex number. Reason is inside this square root it is negative. First one. Second one, inside the roots is negative. So what we got, 4 plus 2, and for this negative we are putting here I, 4 minus 2i. Same as we followed this. K equal to alpha plus ib, k2 equal to alpha minus ib, because this is less than 0. So complementary functions, it will be in terms of cos and sine and exponential term. So k1 and k2, we have to use these 2 roots to find this complementary, functions. So what it will be? It will be in terms of 2 solutions. This is one and there is another one, and adding these 2 solutions we will get the complementary functions. Here adding 2 we get complementary functions. Here we have 2 solutions, this and this, so adding this it comes like this. So complementary function is this one. For this equation, right hand side I put here 0. If we do common e to the power 4x, so it comes in this form. So complementary function is this one. E to the power 4x, c1 cos 2x plus c2 sin 2x. Same as this one. Now we have to think about particular integral, because complementary functions we already got. For particular integral, we have to try a form like this one, similar to this. E to the power 2x, e to the power 2x, there is a constant. Same way, we have to take first derivative, this one, and second derivative, this one. These 2 value to be substituted here, these equations. So if we substitute this first derivative, second derivative in these equations, what we get actually? We get like here this one. This is second derivative, 8 times first derivative, 20 times we have to put the value of y, what we assumed before, and right hand side e to the power 2x. Now more simplifications, we get this. and then we find the value of c equal to 1 by 8. Now this c equal to 1 by 8, we have to substitute in the equations we considered before for particular integral. This equation c e to the power 2x. So value of c, if we provide 1 by 8, so our particular integral takes the form like this. Now here general solution will be same way. We have to get two things. One is complementary functions, another is particular integral. Adding these two, we get the equation like this one: e to the power 4x c1 cos 2x plus c2 sin 2x. It is complementary function, I mean this one yc, and this one yp. So this is the general solution for this equation. That's all for today, and thanks for watching.